Welcome to the channel Quest Edu Physics students. It is your YouTube channel. If you like this channel, subscribe it and please forward the same to your friend students. Here in this class, we are going to learn about the construction and working of a simple microscope, students. What is a simple microscope? The simple answer is it's a magnifying glass. It's a magnifying glass. We use a converging lens. The convex lens as the magnifying glass, and it is the simple microscope. First of all, we have to understand few terms which are related to the simple microscope, students. That means which shows a major part in the derivation of the formula for the magnification. That is least distance of distinct vision and also angle of vision, students. First of all, we have to understand what is the least distance of distinct vision. It's quite simple, students. It is the minimum distance from the eye where we can see the objects clearly. It is the minimum distance from the eye where the object can be seen clearly. For a healthy eye, the least distance of distinct vision is 25 centimeters, students. For a healthy eye, it is 25 centimeter. Often it is shown with the letter capital D, students. Don't mistake it as a diopter. Okay, it is shown with the letter capital D. And the second is angle of vision. It plays the major role, students. It is the angle made by the human eye with the object, students. Generally, this visual angle for the normal eye is 60 degree. The magnifying power of a lens, always depends upon the visual angle only. Okay, students. If you increase the visual angle, automatically the magnifying power also increases. It is the basic principle of simple microscope. The principle is increasing the visual angle, resulting into magnifying power. Okay, students. Let's go with the convex lens, which has smaller focal length. And I already told you, if you keep any object in front of your eyes at a distance of 25 centimeter, you can see it clearly. It is the least distance of distinct vision. Let's go with the construction and working. Actually, we have to take a biconvex lens of shorter focal length, students. Let's say it is the biconvex lens of shorter focal length. Okay. Here I am locating its optic center. Optic center being what, students? We are making a light ray to pass through the optic center, joining the two radius of curvature, students. This is the first radius of curvature and it is the second radius of curvature. Here you know that a lens always have a focal point and the focal length. And what is the focus? It is the focal point or the principal focus. It is the point where the rays will meet after refraction. Here we are taking an extended object, students. It is the extended object. What is an extended object? Which has measurable dimensions. Let's say it's the extended object. We named it as A, B. Okay, students. And we kept this extended object in between the optic center and as well as the principal focus of this biconvex lens. Here we have to remember what the methods of image tracing. As you have learned that to trace the image, we need at least two light rays which are coming from the object. Here we are taking the two light rays, students. One is parallel to the principal axis, it is, and the second one which is passing through the optic center, students. This ray which is passing through the optic center doesn't get deviate. You know this, students. Then it gets refracted and it passes. Here if you observe this one, the gap has been increasing all the time in between these two rays. Okay, students. Here actually we kept our eye very close to this lens. Almost it is in contact with the eye. Okay, students. It is very close. Your eye is very close here. Okay, students. If was these two, they can't meet at a particular point in this way. That's why we are producing them back. Okay, I'm producing it backward, and also I produce it back. The two will meet at a particular point where we will get image. Okay, students. It is the image. We are naming it as A dash, B dash. It is the virtual image, students. It is the virtual image. Now see what we did. We took an object. Okay, the object is kept. What is that in between? Optic center and as well as focus. Let's say the distance of the object is u. Okay, students. And what we did, we formed the image at least distance of distinct vision. It is the D, students. And what is the visual angle? It is the angle made by. Okay. The image with the eye, students. It is, I'm naming it as beta. It is the mechanism what we did. Actually, the eye is very close to us. Here we have to learn one term which goes with the magnification, students, or magnifying power. Magnifying power of a lens can be defined like this, students. It is the ratio of angle subtended by the image. Is the ratio of angle subtended by image to the angle subtended by the object when the object is kept at least distance of distinct vision, students. Okay, students. Here we can define it like this. It is the ratio of angle subtended by the image to the angle subtended by the object when it is kept at least distance of distinct vision. Here clearly you are getting here the angle subtended by this image with the eye here. Eye is very close to this. Is the beta, but we don't know where is the other angle. Yes, say students, I'm producing it. Okay. Here, if it is AB, automatically it is also AB, students. It is A and it is AB dash. Getting me? Then we have to take the angle, students. Visual angle made by the object. It is alpha. Okay. What I said, it is the visual angle or angle subtended by the object when it is kept at least distance of distinct vision. First we see the object without this lens. Here eye is very close here. Then after we kept the lens in front of eye and we adjusted the distance of the object up to B. I hope you understood. What is the magnifying power here? It is the angle subtended by image to the angle subtended by object at least distance of distinct vision. Here these angles I am noting. Beta is the angle subtended by image. Okay, don't get confused over here. OAB, it is the image. Beta is the angle which is related to that, but I am showing that this one. Here I am taking. Here the angle remains same. Okay, students. Then we can write it as beta by alpha. But from this geometry, I am taking the beta and alpha value, students. I am taking the triangle. From triangle, OAB. Okay, tan beta is equal to, opposite is, it is AB by U students. I am not putting any sign convention here. Similarly, we have to go with the tan alpha, OAB dash. From triangle OAB dash, tan alpha is equal to AB. Okay, this AB is equal to AB dash. AB by, it is D. Here also I am not taking any sign convention. We had the alpha and beta and putting here, since they are very small, beta can be replaced with tan beta and alpha can be replaced with the tan alpha students. Then it can be written as tan beta upon tan alpha, and finally we got AB by U divided by AB by D. AB we get cancelled and we will get D by U. It is the formula for the magnification, students. Here the magnification is the ratio of the image distance to object distance. If you keep the sign convention also, you will get the same results. D has to be taken as negative and U also is negative. Then minus minus get cancelled and you get the magnification as D by U. Since it's a ratio, it doesn't have any units, you know that, students. Now we are drawing, or we are getting the formula for the magnification in terms of a focal length of the lens. Let's say the focal length is F, and you know that from lens formula or lens equation, the focal length, image distance and object distance are related like this. 1 by F is equal to 1 by V minus 1 by U. It is for lens, students. Here I am multiplying both sides with the D, students. D by F is equal to D by V minus D by U. Here V is what? V is the image distance, students. It is the image distance. Here image is formed here. Okay, and it can be written as D by D minus, I am using sign convention here. It's a minus. It is minus of D by U, means what? Plus D by U. Here it is D by F. Here D get cancels and we get D by F is equal to minus 1 plus D by U, or 1 plus D by F is equal to D by U. Already we know that D by U is equal to magnifying power. Then M can be written as 1 plus D by F. These are the two formulas which can be used to find the magnification, students. That is magnification in terms of focal length, magnification in terms of least distance and object distance. Here if you see this, object distance is utilized here, object distances disappear. And what is meant by this? Here this formula is for the magnification in case of the strained eye, students. If you form the image under these conditions, your eyes get strained. Okay, students. Eye gets strained means what? You cannot watch the image for longer time, though it has more brightness and its intensity is more. Brightness means intensity. Okay, to see the image for the longer time, we have to form the image at infinity. Okay, students, what we have to do? The same we have to do to get the image at infinity. The same lens, eye is very close to this one. This time we are keeping the object at focus itself. Then we have to do the regular things. One ray has to pass like this. After refraction, it passes through the focus. Because these two rays, they appear to be parallel to each other. It is the object distance is equal to focal length here, students. If I extend them back, they meet at infinity. That means what? V is infinity. Okay, students. Then we are using the same relation. 1 by F is equal to 1 by V minus 1 by U. I am putting the V as infinity here. 1 by infinity is equal to plus 1 by U. Okay, students. Then multiplying both sides with the d, what I get? D by f is equal to 1 by infinity is 0. It is d by u. Here you know that d by u is equal to, again it is a magnification. M is equal to, it is d by f. It is the equation to get the magnification at infinity. Here in this case, maybe the image is not sharp and not magnified as compared to the image which is formed at least distance of distinct vision. Though it lost its intensity, but you can watch this image for a longer time, students. Okay, these are the equations which are related to simple microscope, students. I hope you followed the class. Thank you for watching my channel.